Okay, let's just get started. Welcome to today's office hour. I'm Yao Wang, an AR engineer at Snap, works on the templates and assets. Today, I'm going to show you how to use physics in Lens Studio. Before we start, I just want to mention that you can find the Q&A button and ask any questions during this office hour. I will try to answer them if I get a chance to read it. And if I miss it, you can also ask them in the forum community where you can find the link here. Feel free to ask any questions anytime, and we'll try to address them. Okay, so physics is a super fun feature. It can help you make your lens very dynamic, especially in the AR environment. We live in a world that follows the physics rules, where things glide, bounce off, fell down with the gravity. And now we can also make all the objects in the AR layers simulate the real world effects at the same time. And now let's see a physics magic show. If I click on the preview, then all the letters now have weights hanging from different points and collide with each other. I can then use my mouse to drag different letters. I can even use my head to collide with them, or even use my hand to touch the letters. And you can add all these things to your own lens too. And I will show you how to do that through the session. And this is today's outline. I will, hopefully we can stick to the schedule and leave some time for the Q&A. I will introduce all the physics components in Lens Studio, and I will also show you with kinematics, you can animate some of the colliders. And with recast, you can then use touch input to interact with any physics objects, or even add force to the physics objects. We also support colliding events and overlap events to let you detect whether the physics objects are collide with each other or overlap with each other. And then in the end, I will show you where to find some of the useful assets or resources so you can play with it after today's session. So let's get started with the physics components. We have 5 different physics components in Lens Studio. The first one is the physics world. It lets you define the basic physics world setting, such as gravity, direction, magnitude, and even simulation rate, or even add some slow motion effect. And with physics bodies, you can make the body dynamic, so it follows the physics rules and it moves with the force, collide with other objects. And with the physics constraint, you can constrain the body, just like the letters from the first slide is hanging from one point. And then the physics collider, with the collider, you can make it static or attached to different body parts. And that's why my head is colliding with all the letters from the first slide. And finally is the physics matter, where you can define the frictions or the bounciness for the physics body for the colliders. Okay, let's move to the next one. So let's talk about the physics world. We have a duck here, has a physics body component attached to that and a constraint to a point constraint. And this is just the purpose of the demo. So I will talk about the component later, but let's play with the physics world. In the resources panel, we have this physics root world setting. Here, you can define the gravity and all the other settings for the world. Now it has a regular gravity facing down, and the distance in distance unit in the Lens Studio is centimeter, and the weight unit is kilogram. So that's why the red magnitude, the red magnitude is 980, and we can always make it into different numbers. For example, we can reverse gravity to make it face up. Then we can see the duck is falling down into a different direction. Yeah, and we also support a simulation rate. So with if the value is higher, the simulation is better, but you do trade it off with a worse performance. So you can play with the simulation rate and to see the better result. We can also add a slow step and a slow time here to make the duck move really slow and in a slow motion like this. And additional to that, we also have this maximum speed and the maximum relevant speed. So we can limit the maximum speed for the all the physics bodies in the world. This is because sometimes when the physics body is moving too fast, and we will have this tunneling issue where it just goes through the collision of the collider. So it doesn't look well. So we can limit the speed for all the physics bodies. So we have better and smooth effect. And so this is all the settings for the root world setting. We can actually have multiple worlds in one project. So for example, let's take a look at this one. Let's remove the world setting here, so and refresh. And refresh. Now we can see on the left world, we have a regular gravity. On the right one, we have like inverse gravity. And let's see how are we going to achieve this. We actually have two different world asset here. One is with the regular gravity, and the other one is with the inverse gravity. And we can add a new physics world component to any object, and all the child bodies will just follow the rules for the parent world setting. And here we are assigning the regular gravity to the left world, and for the right world, we're using the inverse gravity. And then it will move to the different directions. But besides that, we can also assign the world setting to specific physics bodies. And this is the third potential ways to assign world setting to different bodies. So now it is the right one has this inverse gravity, but we can assign the regular gravity to the world setting. When we refresh that, we can see both boxes falling down to the ground with the same direction. Okay, now let's move to the physics bodies. We actually have all the examples for different physics bodies. So let's just take a look. For this one, so this is a basic physics body component and how it looks like. And we can define like whether it's dynamic or not. The box on the left is dynamic and the one on the right is static. So if we enable the dynamic flag, as we can see, it's kind of falling down to the ground. And then we can move to the next setting, fit visual enabled. So with fit visual enabled, we can actually automatically make the fixed body fit to the mesh itself, like a bounding box around the mesh. And if the automatic version doesn't serve your needs, you can also disable it on the one on the right. So you can modify the size, like to be a different one here. Let's just refresh it. So now you can see the size is super different. And let's just also modify it to the original ones. Yeah. So this is with different settings for fit visuals, but sometimes when you import a new mesh from Blender and it has offset for the origin and also sometimes doesn't really work with the rotation, you can always add a separate physics body and disable the fit visual and modify the size and change it to different shape type. Yeah, and you can also offset a new offset the body with the mesh itself. For example, here we can add a new body to it. And we can reset it. And we're going to show colliders so you can see it. Let's make it to a different one. And copy the transform from the other object and paste it here. So you can see the different capsule here. And you can actually make the other object under it. So you can add some offset to it. For example, we can add 10 here. So we can see it's actually have an offset with all the physics colliders. Cool, let's move to the next one. Okay, with the next setting, we can actually modify the mass of the physics bodies. And we have this seesaw effect. The box on the left has a lighter weight than the one on the right. For example, this one, we can set a mass from constant kilogram 0.1, and the right one is actually 2. So let's reset the preview and see the effect again. Yeah, so we can see this seesaw effect, and it's pretty fun to make all those effects with just the settings. And move to the next one. We can also define the mass with the density here. The one on the right left has a less density here, and the box on the right have a bigger density, and the spheres have some middle point density. So you can see the left box is floating on top of the sphere, and the one on the right is under the bottom. Cool. Next one, let's talk about physics bodies. So with the body, we have a different shape. For example, we have box, sphere, and we also have this capsule. And this capsule one is pretty fun. We can have three different render mesh visual as a child object of the parent physics body. So it actually moves together. And the last one is the compound shape. This one is a little bit different. All the objects, even the children object has this physics body. So it actually moves together like this. So this is like a compound shape where you can combine different primitive colliders together into a more complex shape. And then let's move to the next one. So this is also a fun one. It's like a more advanced body shape. For example, here we have a balloon. It has a physics body, and we assign it with the inverse gravity. So it always has a gravity phase 2 up, and the constant mass is 5. And we also have a dog here. It has a regular warp setting, which has actually use the gravity from the root warp setting, and it also has a mass 5, so it's actually floating in the air, and you can actually touch it with my hand. The dog is now kind of fly. Yeah, cool. Let's move to the next one. So this is how you make a more complex body, and feel free to ask any questions during the session. Find the Q&A button, if you find anything kind of confusing and too hard to understand. Yeah, okay, since there's no questions, let's move to the next one, the physics constraint. With the physics constraint, we can actually constrain the body into a certain ways related to other sessions or related to any fixed point. For example, we have 3 different fixed constraint. You can see the constraint component here. And it's pretty easy to add a new constraint. You just find the physics body, and in the bottom, you can add constraint object. Once you click it, you can generate a new constraint object under the physics body. And here you can assign it to the target. So this is we're assigning to the ground, and we're using the type fixed. And you can also check the other effects like the point and also the hinge. And I'm gonna show you how what the point looks like. So it's like a dot here, yellow dot. Not sure whether you can see it. Yeah, here. And the hinge is like a cylinder here. So it has a different kind of effect. Oh, for the navigating, I'm using a script. So this is just made for this presentation. Yeah. And with a compound constraint, you can see a similar effect, but this is also working with compound shape here. And you can add a constraint to the parent shape, so it actually constraint with different shapes. Okay, let's move to the next one. Physics collider. And with physics collider, we actually have multiple colliders already. I actually have a collider attached to my head. Let's find it in the hierarchy. Here, the phase occluder. And we can show collider here. Now you can see the blue sphere around my head. And this is the collider. And as you can see, the component itself is pretty much similar with the physics body, except it doesn't have this dynamic setting. So it doesn't really move at all. And we can also change it to different shapes like the box, capsule, cone, cylinder. And we also have this level set, and this is only usable for the closed simulation, and we cannot really use this setting here. And let's just switch back to the sphere. And we can also make it to fit visual or not. And you can also make it force compound. And this is very useful when you are using it for the compound shape and you are trying to collide it with a recast, and it will automatically return the parent object rather than the subparts. And you can also enable smoothing. And this is very useful, you know, when the tracking is not super stable. So when I move super fast and you have this glitch with the tracking, this will allow you to have super smooth transition. And also you can make, so now I can collide with the letters. You can also make it intangible. Here, now you won't see any effect anymore. This is because this is very useful when you are trying to use it with the overlap event, even though the colliders can pass through that, but you can already, you can also catch it with the, overlap event and trigger some certain events. So my camera zoom doesn't work anymore. Okay, here we go. Yes, so that's the one for the physics colliders, and we have some questions here. Yeah, it is this is just my camera settings. So we have a question: has it got a Z depth? So this is just the camera settings, and the script is like here. I have a special slide folder, and you can find the script here. I mean, I won't show you the details, but it's just to show if you click on the left, you can go to the previous page, and click on the right, you can go to the next page. So this is a script for my slide. Yeah, any other questions? And we will share all the projects later after the session. You can find the whole project. Okay, if there is no other questions, I will just move to the next page. Okay, physics matter. So this is also a fun one. Let's just find the correct object. And as you can see here with the physics body, we can assign the physics matter to it. Let's find the frictions here. So with the physics matter, you can add new ones within the resources panel. And here you can define the friction, the rolling friction, spinning friction, and bounciness. And even static bounciness for the collider or the ground. It can also have different kind of parameters. And here, the box on the left has like less friction. So it's super slippery. It already fell out of our wheel. And the one on the right, it has like this maximum friction is this one. So it already paused on the ramp. And next one, we also changed the rolling friction. So the one on the left now has the maximum rolling friction, and the one on the right has the minimum one. So it's kind of slippery and rotating on the ramp. And next one is the bounciness. Similar here, we have different bounciness assigned to the object. So we have the bounciness changing, as you can see here. And the one on the right has the maximum bounciness and it's bouncing forever. And the one on the right, on the left, it doesn't have any bounciness at all. So you can use physics matters to achieve a different kind of visual effect, and super fun to see the result. Cool, let's move to the next one here, the kinematics. With the kinematics, so kinematics is just a fancy word, so you can actually use a twin script. It's one of the main helper script to add animations, and you can actually animate the colliders. And for example, you can add position change, scale or rotation to all the physics colliders. And then if you attach any physics bodies to it and constraint constraint the point constraint with it, you can see like some dynamic effects. Let's take a look at how it works. So here with the wheel, we have this twin transform, and we're going to add this loop constant rotation to the wheel. So it's rotating all the time. And we add all those physics body under it. So as well as the boxes with constraint to each point. So you can see this dynamic settings here. So it's kind of moving. And then the next one is the bungee jumping here. We have a blue box. We're making it change with the scale. So it's changing scale. Looks like someone is like the blue box is jumping right now. And then, yeah, so this box, you can also like drag it. It's so hard to catch. Anyways, here, yeah, so you can, make it scale. And then the last one, the drop tower, where you can change the position. So it's moving up and down. And then you are attaching a bunch of sphere and constraint to the colliders. So it can move up and down. So you can achieve this really amazing and dynamic settings with other examples. And the last one is the train. So here we have like a train origin, and we're also adding this forward looping effect to the train. And then you can, drag the train into a way and interact it with the recasting here. So this is just the kinematics. And let's move to the next one, recast. Okay, with recast, we actually have this helper script called recast script, where it like you define 2 points. Here we have 1 point, the other one is on the bottom of the cannon. You can, once you can draw a ray between these 2 points and then make it collide with any physics objects. Once the hit happens, we are going to trigger this script called canon recast example script is called set heat, and you can set the heat state for the bird, so you can kill it in a way to not really kill it. It's just like set it to be dynamic, so it fell with the gravity. And besides that, we also have another one here. You can actually tap on the screen to kill the bird again, and it's triggered with exactly same script, but with different settings. Here, instead of using the from point to point, we'll actually use the on-screen touch and assign the right camera. Then you can recast it to click on the bird and project this ray from my touch point to the bird. So once you had catch this heat event, you can then trigger different heat state for the bird. And there are also other settings like recast all. So you can hit two birds at the same time, like this. And the recast without recast all is just trying to find the nearest object, and they will just hit it. And you can also output the heat debug, so you can get some additional information here in the logger. Yeah, you can get a bunch of additional information here. And if you want to know more detail around this, like what all the parameter means, you can always go to our documentation page and find the recast. You can find all the examples here and like how to create with specific script and set different filters. And then this is the difference between the recast and the recast all. So you can kill multiple birds at the same time. And these are what it means for different parameters. Yeah, just take a look at the website. It's super useful. And then let's move to the next one. Set velocity. Here, we can achieve this by tapping, like we can tap on the screen and shoot the bird out with the cannon. So we can achieve this with two different effects. The first one is the behavior script. So you can initiate a new prefab called chicken physics body. We also have it here. With the body here, we are actually attaching another behavior script under the prefab. So when the new prefab initiated, we will trigger and add a new response to it. We're going to apply the force to the body, and we're going to make the force type to position and the mode to set velocity. And we're going to add a minus x-axis direction for the velocity. So it's relevant to the cannon. So even though the cannon is moving, it still have this nice direction. It's just at this specific direction, and it's related to the cannon object. So even though it rotates, it also have the same like direction to shoot out. And you can also achieve this with the physics API here. So rather than use the behavior script, we're actually going to trigger the launch function. Let's just take a peek at this function here. So this is a launch cannonball function. If you take a look at the script, it's actually not that a lot. You just add this launch effect here, and we're going to generate a new cannonball and a new object called new cannonball, and then we're going to enable it. And we are going to apply the transform to the right position, and we're going to get the component and add the velocity here. And you can also add the angular velocity to the cannonball, so it has more dynamic effect. Yeah, so this is how it works with the basic physics APIs. Again, you can find all the details on our documentation side. It's pretty easy to achieve all those effects. Cool, and this is the link to the launch cannonball script, and you can define the speed. You can make it higher or slower, or add the angular speed. Cool, let's move to the next one, add force. So we actually allow you to add force and set velocity for all the physics bodies with all different mode. And you can see we have so many different modes. And you can find it on our documentation website too. Here you can find a script, like for example, add force directly. You can add force at a certain location with a little offset. You can add to the torque, so it only rotates. And you can even add relative force, all those stuff, and set velocity to different bodies. Here is just a like visualization to see the difference. For example, you can add force to the mass center with velocity change. You can add accelerations with a certain durations. So it has this longer effect. You can have this impulse and add force directly. And you can even add force with offset. So it's not add to the mass center. So it doesn't really only move with position. It also has this like spinning effect. We clicked the wrong part here. And then, for example, it rotates and also moves. And you can also add force to the rotation only. So it changes here. Oh, that cube really want to move to other place. And then let's move to the next one. So with this one, we're going to detect a collision event. Let me just disable the piano sound for now. But as you can see, when our master monk's feet collide with the piano, it can trigger the different sound. Here, we can also do that with two different ways. One is with the behavior script. And with the behavior script, we're actually have this behavior script attached to each key. And then when the collider event happened, when the trigger entered, we will add the response to play a sound. And we are adding all those different scripts to each keys here. And we can also add some flags to the collider. So you can define the other objects or other names to assign it to specific ones. For example, if I'm clicking on the piano key or my hand is not triggering any sound anymore, even though my head has a lot of collider on top of it. So it only collide with specific objects, for example, the monster's feet. And this is using the behavior script. And there are also other ways to trigger that, which will be the physics APIs here. And this time we're actually attaching the script to the marker's feet rather than the pianos. Let me just find where it is. Yeah, it's right here. So we have this collision event script attached to the monster's feet, and you can print out all the collision event. You can see the details here. So for example, the right feet is stepping on the body. It has this collision event, and the contact is the touch point is only one, and you can see all the details here. And so once the collision event happens, we will actually trigger the effect on the piano, so we can trigger it and play the sound with this play note script. Let's take a quick peek. Here we can press the key, change play the sound, and change the material, achieve all those effects. So yeah, so we can detect a collision event. But one note here is for the collision, we can only detect the collision with dynamic body rather than all the other colliders. So it's attached to the dynamic body, and it happens all the time, whether you listen to it or not, you add an event to it or not, it happens all the time. And that's the main difference between the collision event with the overlapping event. We're going to show it in the next example. Here with the overlap event, we are actually going to listen to a different event, and you can add overlap event with different physics bodies or colliders or even static colliders. So you can have your own flag here. So include a static collider or include dynamic, or even the intangible ones. Intangible ones will work with the overlap event, and it won't be achieved for the collision event. The collision event is only works with the dynamic body. And here the effect we're going to achieve is when the little rider enter into the red bridge, it just change its color to red, and when it enters into the blue one, it's the blue figure here. And we can also achieve this with two different kind of script. One is the behavior script. Again, you can also change it to set it to the physics collider event, and you can specify which collider you want to collide with. Here we're choosing the right kernel collider. We can show the collider so you can see it here. So even though it's like intangible, we can still detect overlap event. And we add event temp to be enter. And we also say this will work for specific physics bodies. And the trigger will be set the red color to the specific body. And then this is with the behavior script. We can also make it work with the physics APIs, and you can just see this script here. Once we have this overlap, enter, and then we're going to update the color. So for whatever objects, fixed bodies enter into the zone, then we can update the color. Cool. Let's move to the next one. So we also have some additional examples here. Let's disable our slide camera, and then it's gonna take a little while. I have too many objects under it. Let's enable the face camera first. Here we have two different examples here. I have this chain effect, and I can touch it with my hand. So this is a very easy example. Actually, you can attach different constraint to the component shape and then attach that to your ear. So you can change it, like attach to different body part. And we also have this default hand here, so you can add different colliders to the hand, and you can touch the component shape and make it really dynamic. We have another example here which demonstrates the physics matter here. We can use different fixed bodies as assign different methods to see different effects. For example, this tennis ball is pretty heavy. And then if we switch to the beach ball here, we can see it's really has this bounciness to it. So in this way, we can define different matters to different kind of the body and to make the visual effect more realistic. And for the box, we can see this rolling effect here. So it's really like we can define a shape type to be box and we can rotate it. So it has a higher rolling friction for the box. So we can see different effects here. And next one, let's move to the world camera example. And let's also set to the interactive panel. And reset the preview. Oops. Let's see what's going on. The object is not showing up here. Did I disable the camera? No. I don't think the object is showing up. Let's switch to a different camera to see whether we can catch it or not. Oh, I see. I'm on the front mode camera. Now here we go. Let's go back to the previous example. So here we have a duck way like on top of a pool. And with interactive panel, you can move closer to see the effect. Here we have the duck, and this is just a advanced example to show our physics physics system is really advanced. It can take up to 100, 200 like physics bodies when you push it to the mobile device, and 100 when you push to the spectacles. Yeah, it also works on the spectacles. If I tap on the screen, we can make this duck fall into the pool, and as you can see, we can play with duck with the like all the balls here. And let's move to the next one, the wind zone. And we also have this like additional script that add force to specific bodies and add this wind zone effect to it. And next one will be the 3D physics here. This is kind of similar to the slide, the first slide I showed. If you tap, it can just fall down onto the floor. And then move to the next one. So here with this example, we can tap on the screen and to enable different kind of like objects on top of it. And here we have a small car. We can long press the screen to make the car move. And then once it entered this slow motion zone, it just has this slow motion effect. So this actually allows you to change the, you can always change the simulation rate or whatever settings for the world during the runtime. So you can achieve this kind of interesting effect. Yeah. Okay, that's pretty much all the examples I want to show. Let's go back to our slide. And here, let me just show you where we can find all the additional resources. For example, we have two different templates for physics. The first one is physics, and the second one is physics toys. You can always find the templates from the homepage of Lens Studio. And then you can also find additional assets from the asset library. We have 5 different assets in the asset library. For example, we already showed the draggable script where you can use recast to interact with any physics object. You'll also see the wind zone effect. And with my head, you can collide with other objects. And with the hand, I can touch the different letters on the screen. And finally, we have this full body physics collider. Let's just go to the asset library and find our full body collider here. Let's import it into our project. Okay, cool. Then let's drag it under the slice camera. Take a little while to load, and let's disable our slide. Cool. Let's go back to the camera mode. And we need to add additional camera to our heart object here. We need to assign the slide camera to it so it knows where to generate this heart. Okay, now I have the full body tracking around me. So those are the colliders, and I can also, catch the heart and collide with the heart, achieve all those kind of effects. It's pretty fun to, generate all those kind of effects here. And let's also switch to the preview. Let's go back to the front body here. So as you can see, the floor collider here is really smooth, even though the body is moving backward and forward. We have this like enable smoothing enabled for the floor collider, so it always has this smooth effect, even though like if the person is jumping around, we can still have this smoothing effect attached to the physics collider. So it's super helpful to have this kind of effect too. And when the heart is touching the ground, we can then change the size of the heart and then destroy the heart to save some performance. Yeah, so this is the additional asset here from our asset library. And again, you can find all the additional docs with like in our website. Here, you can learn different specific events if you are interested into it. And this is like all for today's session. Hope you find the physics is a really fun feature. And I think the best way to learn is to just get started and attend our hackathon. So you can actually build something with the physics, and really looking forward to see your amazing projects. And we will share today's recording and all the relevant resources. Let me know if you have any questions. Okay, here I have a question. Do I need to make iKey in Blender? So I don't think we can do that right now. So for the physics constraint in the Lens Studio, it's very limited right now. For example, we don't have, we do have point constraint, but we don't have the like constraint to the position or the angle. So we cannot really make a super fancy like ragdoll or any other stuff with the Lens Studio, like with the current system yet. But in the future, we're definitely going to address most of them, like to make it better. And the can force will be with the phone, like throwing. Yes, definitely. You can touch on the screen and then add a force to the physics bodies to make it move. For example, we have this examples like where the bird shoot out with the cannon. So instead of the using the touch screen, you can even use gyroscope from the phone to make it work. So you can have this throw effect, and you can estimate different the movement, and then add this shoot effect to different bodies. So you can shoot it and make it add force or set velocity to different body. And any other question? And if you feel today's session is super hard, again, you can find all the resources, within Lens Studio, and also you can to read all the documentations from our website. It has, all the resources. For example, if you don't understand what the word setting means, you can find all the resources here and just read what is a gravity and what is a physics matter here, and how to change it with a specific APIs, and what the friction means, and what are some of the calculations, and what is a rolling friction. We also have a lot of sheet here, so you can get to read. For example, we have the bounciness, like the one with the high bounciness and all those stuff. Cool, I think that's all for today's session. Yeah, please join the hackathon, and really looking forward to see your project. Cool.